So, we will do energy transfers in MHD now. Okay. So, similar, well, generalization of hydro is quite complicated, but if you are got a good hang of hydro, then you can easily do all of it. So, the equation for energy, now maybe I should write down equation for energy. So, we wrote equation for the nonlinear term. So, I think let me write down and we go back. No, I do not have a slide. So, let us write down here equation for the energy. So, what is equation for kinetic energy? So, it is mod UK squared by 2, modal energy, no, this one. So, the first nonlinear term will give you u dot grad u. So, that will give you k dot uq up dot uq. In fact, have you done it uk star, right, sum over p's, right, is that correct? I mean, this will come, so nonlinear dot u star. The next term is right hand side is minus grad p. So, grad p gives you 0, right, because pressure is in the k direction and I am taking dot with uk, so it is 0. So, you get only the term for b dot grad v, which is this is I sitting here, I k dot bq bp. Now, dot with what? Dot uk star, sum over p's, q is k minus p. So, this I drop the viscous term and this is the equation for energy. Now, you write down equation for magnetic field, dk square by 2, then you get I k dot k, no sorry, k is inside in the above, k dot u of q b of p dot b star of k, and the right hand side is I k dot, no, it is, remember, is b dot grad u. So, k dot b, b of q, u of p. So, the difference here is who is the mediator, u of p dot b star of k, just straightforward. Okay. So, this is what I wrote in the next slide. So, we have two terms. Now, I just rearrange them. You take left hand side, right hand side. This is a UU transfer, which is coming because of UU terms. This is like hydro. There is no difference between hydro and formula and this formula. There is a UB term, which is this term and this term, UB term. So, this is coming from b dot grad v. Now, we got BB term, which is here. Here UQ is the advector. Remember, it was in the left, u dot grad v. Now, the last one is b dot grad u, which is here. Now, b I keep as total b, but today's lecture I will not really emphasize, but it is very convenient to keep total b to see the effect of b naught. Okay, but we will not belabor on it. Okay. Now, from this you can easily see that how to get to mode energy transfer, right. That is what we did long time back in 2001 with my student Gaurav Dar, Gaurav Dar, his full name is Gaurav Dar, and Ishwaran. Okay, 2001, Physica D. Okay, so let's see the how the modes look like. So let's focus on a triad, right? We focus on a triad, only mode to mode is in a triad. So we have three magnetic fields, magnetic modes, Bk prime, Bp, Bq, and three velocity modes, Up, Uq, and Uk prime. Blue is velocity and green is magnetic. Now these are exchange of velocity among themselves, right? U to U transfer. Now this is a B to B transfer, which is coming from which term? The u dot grad B term. That has to be in B squared, mod B squared by 2. So this term will be the term responsible for B to B. It does not talk to you for energy transfer. He is talking to you for mediation. So, here U is a mediator. So, for these transfers U is a mediator, but there is no exchange from U to B. Now, these red lines are energy going from U to B. So, energy, magnetic energy can grow or can decrease by these red lines, and that is coming from which term? The other term, B dot grad U dot with B. These are responsible for this reduced one. So, we write this as SBU. So, our notation is right to left. The giver is in the right, receiver is in the left. Okay, that is the notation we need to keep, and we write K prime PQ. So, P is the giver, K prime is the receiver, and we have red lines which are U to B. Is the energy transfer from B to U? Yes, because if you write equation for U squared, UK mod square by 2, then we have minus U dot grad U dot this with U plus B dot grad B dot this with U. Well, I should not really write K, this one. This is in real space. So, this is the energy transfer from B to U. B is the giver and U is the receiver. It is from green to blue. In fact, that should be equal and opposite. No? So, you can see that, you can easily see from here, if for mode to mode by property K prime PQ, here U is given to B, you can write this as UB, P is the receiver, K prime Q with a minus sign, straightforward. No? So, this is better, this is like energy is here like a quantity, it is like probably money or any, this is a property of transaction, any transaction by scalar quantity, that is what it will happen. It should follow these laws. So, we can follow a similar derivation. So, what I have in the previous slide is combined energy transfer. Previous slide was UK was getting from both P and Q. Now, we can derive in the same lines, which I will not derive it here, but we can, I will just give you the formula. No. So, I will just write down the formulas. Okay. So, what are those formulas? In fact, you can easily write them yourself. So, let us write down the formulas. SUU and SBB I do not need to write, correct, because you have done it in the past. SUU you have done before. SBB will be like what? Like the vector which I did, so that is advection coming from U dot grad omega W. So, let us write for completeness I write S K prime BQ is minus imaginary K prime, so is between B and B. So, BP dot B K prime and use a med vector or use a mediator. So, UQ. So, this is SBB, fine. Now, this we can write down how much goes this guy SUB, SBU. This is the SBU term, this one. So, who is the mediator? This B is the mediator, this B, right. So, to the left of grad is the mediator, okay, that is what I was. So, think term coming to the left of grad. So, this is, if you write this del J Bj Ui dot with Bi, correct. So, who is the mediator? Bj, B is the mediator. So, you write K prime, B is the mediator, so B of Q. Mediator we write as Q, that is our standard notation. Q is the mediator here, fine. And we get, who is the receiver? BK, BK prime, so BK prime, and who is the giver? UP, so UP is the giver. UP. So, this is intuitive, H vector is to the left of grad, and giver is to the right of this is a giver and this is a receiver. Okay, straightforward. What about SUB? K prime PQ minus imaginary. So this coming from here, right? SUB. U is getting from B. So who is the mediator? This B is the mediator. So K prime dot B of Q. And who is the receiver? U of K prime. This is the receiver. U K prime. And who is the giver? BP. This B is the giver. Okay. So these are the formulas which we can write down. And from this we can get fluxes, which I will describe in a soon. Okay. So these the terms here and here, they are responsible for energy going from one to other. Now, so you can see that there is a U to U transfer, B to B transfer, U to B transfer, and B to U transfer. But if you look at Z plus Z minus, the equations are simpler. Now, without proof, I am also telling you that if I look at, I sum up over a triad of SUU, these triads, they sum up to 0. Now, I am not proving it. This sum of these SBB, if I sum over all the modes in a triad, they are 0. And if I sum these two together, then they are 0. Okay. It has important consequence, but I will not repeat. I will not discuss, sorry, not repeat, I will not discuss. Okay, let us look at energy transfer for Z plus Z minus. So here for Z plus mod square by 2, what is the form? It is Z minus dot grad Z plus, correct? So who is going to whom? Z plus is giving to Z plus, this is giving to this, and who is the mediator? Z minus. So it's straightforward, you can write down energy going from S Z plus K prime PQ is, here there is no minus sign, there is a plus sign. Why is there a plus sign? There is a minus coming from this minus or this minus here, but these are plus signs. Huh? These are plus signs. So the sign difference between SB and SU and SBB and SUU. Okay. Here there is a minus sign here, so there is a minus sign here as well. Now proof is a bit involved, but you can see the signs we have to be careful. I am doing mode to mode, no? So minus imaginary K prime, who is the giver? Z minus is the giver, Z plus the mediator, Z minus is the mediator, Z plus is the giver, P, and Z plus K prime is the receiver. What happens with the minus sign? Z minus exactly same with minus flip to Z reversed. So let me just write this equation. So this becomes minus, this becomes plus, this becomes minus, this becomes minus. This is total symmetry. And whether the B naught term does not do any nonlinear transfer. There is a alpha term, no, B naught dot K. That term has no nonlinear, because there is only is a linear term. So there is no nonlinear transfer coming from that. There is interesting linear transfer, but we will not discuss today. So we can write down equation for Z minus as well. K prime PQ is minus imaginary K prime Z plus of Q, Z minus P, Z minus K prime. Okay. So there is energy transfer from Z plus to Z plus, Z minus Z minus, there is no transfer from plus to minus. So this is convenient. So in fact these are better variables for turbulence modeling if you are looking at energy transfers and flux than UB. Though UB are measurable, that is what we measure, magnetic energy, kinetic energy, but they are very useful variables. Now what about the flux? So these are the fluxes for UB. Okay. So we have two spheres. You can see the U-less sphere, this one, and B-less sphere. So, these are, so basically there is only one Fourier space, but I am writing, I am giving you one B sphere and U sphere or the same radius, okay, same radius, the both of them are radius k naught, clear. Now, so we can define many 6 fluxes. So, what are those fluxes? So, modes inside the sphere for U to modes U modes outside the sphere, that is Kolmogorov. So, pi U less to U greater, pi U less to U greater of k naught, that will be S U U, right, it is going from U to U, correct, S U U k prime, let us not use k prime, k p q, where is p and where is q, where is k, p is less than k naught and k is greater than k naught. So, this is usual Kolmogorov, this is velocity stuff, and the formula is exactly same as what we did for hydro. But now we have 6 arrows, you can see there red and green, the 6 arrows. So, there is a B to B transfer as well, this is B to B transfer. So, what is B to B transfer? So, we write pi B less to B greater, this one k naught. What is the definition? So, B less to B greater, which is SBB. So, B to B, no. So, giver and giver is this is giver and this is a receiver. So, k p q, giver is within the sphere, receiver is outside the sphere, fine. You can define from, let us say this one, this guy, U less to B greater. So, what is that? Pi U less to B greater. So, now what should I use now, please tell me? Yes, SBU, U is the giver to B receiver, k p q p less than k naught, k greater than k naught. Similarly, you can define these guys, B less to U greater. So, B is the giver, U is the receiver. Now, all this seems, why are you doing it? But I will tell you why we are doing it in 10 minutes. But there is interesting transfer, this one. So, who is the giver and who is the receiver? Pi B less to B, no sorry, pi U less to B less. Remember this one, you can see this in the screen, is very small. This one, pi U less to B less. So, what should I write here? Is U is giver, B is the receiver, k p q. So, k is a less than k naught, because receiver is also in the sphere, but it is a different field, it is a B field. In the same house we have English, we have some X people and Y people, and they are exchanging, okay. So, there are two different, so k less than k naught and p less than k naught, less than equal to I put, okay. So, just to, now you can also define energy going from larger to larger, U greater to B greater, then the modes will be outside the sphere. So, you just change the sign to greater, okay, and they are useful for dynamo, okay, which we will discuss in 10 minutes, fine. Now, so these are 6 fluxes actually for U B variable, there are 6 fluxes. What about Z plus Z minus, how many fluxes do you expect? 2, great, very good. So, for Z plus Z minus there is only 2 fluxes, for the Z plus channel and the Z minus channel, there is nothing across. So, there is across ones are not there. So, we have pi Z plus k naught, which is S Z plus k p q, k less than k naught, no sorry, p less than k naught, no, p is the giver, and k greater than k naught. So, this is for Z plus, and Z minus will be just change Z plus to Z minus. this is convenient, there is only 2 variables. Now, by the way, these variables get dissipated. So, their dissipation here, in fact, I am quite incorrect. Yeah, so there is a, it is okay. So, this is a dissipation here of Z plus and there is a dissipation here of Z minus. Okay. So, in the earlier slide, there is a dissipation of magnetic energy and kinetic energy. So, let me just make a remark, because I think this we need this. Here, you find that all the magnetic energy here is dissipated at large wave number, right. So, that is where they are effective dissipation. A kinetic energy is dissipated here. So, how much energy is dissipated? Kinetic energy. Is it just pi u less to u greater? This one or more? Is more, because energy coming in is under steady state. You force at large scale here, so here the energy is going from this one, but there also there is another source of energy, B is given to u. So, under steady state all the energy coming at large wave numbers must be dissipated. So, energy coming in here will be this plus this minus this, because according to this notation is going away. So, whatever coming here net must be 0 under steady state. So, there are lots of formulas we can derive on the properties of these fluxes. Okay. For example, under steady state, whatever energy coming in here, B is getting some energy, B sphere. Under steady state, this sphere should not get any net energy. So, means whatever comes in is going into this and this channel. Understand, no? So, if I have my income does not change, then whatever I get must be given away or dissipated. So, right now it is not getting dissipated because it is small k, it is just distributed. So, you can define this laws for the fluxes. Okay, now we can also define mode to mode transfer, sorry, shell to shell transfer. So, this S2 is shell to shell transfer. So, there is U to U transfer from shell N to shell N, there is a B to B transfer, shell M to M shell. Also, we are transfer from U to B and B to U. So, there are 4 shell to shell transfer in terms of UB variables. Okay. We can define we already defined it, but there are 4 of them, we should keep in mind. And for Z plus Z minus, only 2 of them. So, there is nothing cross, and Z plus Z minus there is only 2 of them. Okay. So, these are nice way to compute these quantities. Okay. So, we stop. Thank you.